everyone. This video is going to be about quantum numbers, and we're going to be trying to visualize them as best we can. Here's an example homework problem, and it's telling us the contour representation, that's just referring to this diagram here, of one of the orbitals for the third shell of a hydrogen atom is shown. That's what we're looking at. So the first question, what is the quantum number L for this orbital? Let's kind of think through this. If n equals 3, what are the allowable values for L? Well, just as the number of floors in a building depend on what building you're in, the values of L depend on n. So the allowable values of L go from 0 to n minus 1. So L can be 0, 1, and 2. L not only has numbers, L also has symbols. So if L is 0, we call it S. If L is 1, we call it P. And if L is 2, we call it D. And do you remember what an S orbital looks like? It was spherical, wasn't it? Do you remember what a P orbital looks like? It was dumbbell-shaped, wasn't it? And do you remember what a d orbital looks like? Well, the d orbitals were kind of crazy, but they did have 4 so-called lobes. So looking at the diagram that they gave us, we've got a p orbital, right? That's the picture that they drew. So the value of L then is 1. So now, how would we label this orbital? Well, it's in the third shell, so we would call it a 3p, and because it's on the y-axis, we would give it a subscript y. Now in part C, in which of the following ways would you modify this sketch if the value of the magnetic quantum number m sub L were to change? So before we read all of our options here, let's think about m sub L. We know that for this orbital, L is 1. And just as the number of rooms depend on what floor you're on, the values of m sub L depend on L. And if you remember, the values of m sub L go from minus L to plus L. So if L is 1, m sub L can be minus 1, 0, and plus 1. And what these values refer to are the three-dimensional orientation of this p orbital in space. 3D orientation in space. So the diagram that they gave us is showing this orbital with some orientation. It's on this y-axis, but it could also be on a different axis. So I like to show my x-axis coming out of the screen towards you. The y-axis is in the plane of the screen, and so is the z-axis, but it's going up and down. So another possible orientation is this p orbital could be on the x-axis, coming out of the screen towards you. And then one final orientation could be that this p orbital is located on the z-axis. So here it is, I'm sketching this p orbital on the z-axis. So notice that we have 3 different values for m sub L, minus 1, 0, and +1, and we've got 3 different orientations of this p orbital. We've got p sub y, we've got p sub x, and we've got p sub z. That's what these quantum numbers for m sub L are referring to. So can we answer the question? In which of the following ways would you modify this sketch if the value of m sub L were to change? It would be drawn larger. No. The number of lobes would change. No. Look, in all of my sketches, I still have 2 lobes. The lobes of the orbital would point in a different direction. Yes, I think that's it, right? Is it on the y, or is it on the x, or is it on the z axis? This one, there would be no change. Not true. So this is the correct answer, and I hope this video helped you to visualize quantum numbers. Thanks for listening, and good luck.